see a pattern? What would the pattern be?
Multiplying by negative value.
So multiplied by -1/2. Let's make a full sentence. Any entry in this particular sequence obtained by its predecessor just by multiplying by -1/2, you said. And if you're going to say it that way, it sounds to me like you're coming up with a recursive formula by sequence. And recursively speaking, with what you just said, any term in the sequence can be generated by multiplying its predecessor by -1/2. Oh, but shoot, with the recursive description, this isn't good enough. I have to identify what the very first entry is. Of course. How could you and I generate this sequence, define it, with an explicit formula? So times -1/2 to the what? Yeah, I agree. Do you guys agree? Do you think we can write it differently? Could you and I rewrite this as, I don't know, positive 3 over -2 to some power? That was a question for you to answer. To the power of? To the power of?
N plus 1.
Do you agree? Way too much silence. Don't listen to me. I'll come back. Let me prove it to you. Because I think I've got a 3 times -1 to the n minus 1. All over 4, which is 2 squared, times 2 to the n minus 1. It's just downstairs I get to add exponents. But that's the same thing as 3 times -1 to the n minus 1 all over 2 to the n plus 1. But I think that's the same as 3 times -1 over 2 to the n plus 1. You know what, you guys? With that exponent for -1, I could choose this exponent to be anything involving an n plus or minus any odd number. How about this one? So that I can combine it with what's downstairs. Now do you believe me? I don't feel confidence oozing from you.
Say the last part again.
I'm saying this. You need from here to here or from here to here?
Yeah, from there to there.
Remember that?
Well, actually, yeah, from there to there.
You got to confess that what I'm suggesting is that I've got a toggle switch here. This negative sign being turned on every other term. And I think it doesn't matter what power it raises to as long as it's the power of n plus or minus some odd integer. I didn't think I said it. I'm kind of crude. I said n plus or minus. I meant to say n plus any odd integer is going to give me the same result. And therefore, I just refer to the export as n plus 1, so I can absorb it with the base downstairs. Nice.
So you could say 3 times -1 to the n power? Does that flip the order?
That would flip the order of the negative signs. Yeah. Okay, you don't like what I said. Deborah, I'll do it a different way. How about this? Copy. How about this? Copy. How about this version of 1? Happy? Because that's just 1. Oh, but these bases are the same. Now let me add the exponents. Don't I get that? So if you don't like the way I said things, I can look at it differently.
But you can't do that to just the top.
Sure, I can. I can do whatever I want. Is that this times this? All of
Build
this.
math, you will create it.
It's just that since these exponents are the same, I can kind of concentrate on their bases and actually literally combine those bases because, again, the exponents are the same. I think this is nothing more than 3 over -2 to the n plus 1.
Well,
Is this an example of the explicit formula and the recursion?
You know what? You're right. What I was trying to generate right here is an explicit formula for my sequence. And I'm trying to suggest to you that the nth term could be expressed in exactly this fashion. And if you think I made a mistake, you guys just dive in. Plug a few values of n in and see if you get what I generated over here when I wrote the sequence down.
So this would be the...
This is the explicit formula, whereas this is my recursive description. fact, I think examples 1 and 3 are kind of interesting. I think in example number 3, look at the recursive formula. I simply generated any term in my sequence by multiplying its predecessor by a constant, but with an arithmetic sequence, sorry, I misspoke. With the first example, if you look at the recursive formula, I generated a term from its predecessor by adding, not multiplying by something. When I add something to a predecessor repeatedly, I refer to that or subclassify that as an arithmetic sequence. You guys saw this back in college algebra or pre-calculus. Whereas when I generate an entry in a sequence by multiplying its predecessor by something, I subclassify that not as an arithmetic sequence, but a geometric sequence. And this one clearly is geometric, isn't it? Do you remember all the business or not? Kind of. So everybody, before I dive into my next example, I need to talk about the formal definition. Actually, before I even state it, can I look at a pretty picture? Here's my horizontal n-axis. Here's my vertical y-axis. Let's see what I talk about a line. Y equals L. Now don't yell at me. But if I deviate from L on the y-axis by no more than epsilon units, and I consider a horizontal band about y equals L, whose width is 2 epsilons. You take a peek at this picture. For n equals 1, here's the first term of my sequence. For n equals 2, here's the second term of my sequence. For n equals 3, here's the third term. And it's popping up all over the place. You guys, what I'm trying to imply is that with these dots, they're getting closer and closer to L. Maybe popping on either side, but getting closer and closer to L as n increase that bound. This kind of sounds like what you guys studied back in Math 30, namely
Delta epsilon.
your epsilon delta definition limits. You guys, I think I need to tweak it a little bit. Technically speaking, check this out. For this particular value of n, let's call it big N. I want you to look at my picture. Is it not true that for every little n that's at least as big as big N, that a sub n is within epsilon units of L?
Is little n every other point?
N is just a value on the horizontal n-axis.
Okay. Do you say that again? So it's
Yes.
and so-
Do you think it's true that for every little n bigger than my big N, the nth term of the sequence is within epsilon units of L?
No.
Oh, you're right, I made a mistake. Oh, that one I guess is beyond that epsilon radius of L, isn't it? So I'll restate that. How about this is my big N? Now for every little n strictly bigger than big N, is it not true that a sub n is within epsilon units of L? What's that? Oh shoot, I still made a mistake. But my point is this. It looks to me like eventually I can find some big N that has the quality that for every little n bigger than big N, at least now in my picture, this is what I intend, that a sub n is indeed within epsilon units of L. Let me formalize this in a definition. I will say, given a sequence, like this one right here, the limit of the nth term as n increases without bound is equal to L simply means the following. That for all values of epsilon that are strictly positive, there exists a big N such that in absolute values, the difference between the nth term of my sequence and the limiting value is no more than epsilon units whenever n is chosen big enough. And as a matter of fact, if a sequence has a quality that its nth term goes to something called L, as n increase that bound, I might even say that the sequence itself converges. And specifically, it converges to L. So you guys, humor me. If I take a peek at something like, I don't know, how about 1 plus, I don't know, 2 over n raised to 3n power? If this is the nth term, does this particular sequence converge? Does a sequence with this as nth term converge? Yeah, I think it does. How do you find that? What it converges to?
Take the limit of this.
Take its limit. So if I take the limit, as n increases that bound, of my 1 plus, I made this up, you guys, am I writing it correctly?
Yes.
Yes.
Should be
So how do you
2
take the
over
limit?
the x. Should we convert them to x's?
We can x. Why are you changing things to x?
The n's are integers, that's not continuous, you can't take the limit of non-continuous.
I can now, because I just defined what it means.
Before you continue, can you read the definition specifically here?
It might be too sloppy. Sorry.
It's not sloppy, it's just, I don't understand where.
The limit, the base of n, as n increases that bound, is equal to L means that for every epsilon strictly greater than 0, there exists some big number called a big N, such that the nth term is no more further away from L than epsilon units, whenever little n is chosen big enough. That's how I might rattle it off with words.
I thought the
Jeremy?
such that symbol was the long R.
It is when it comes to set builder notation. And at higher level mathematics, since we don't typically use a notation, we steal this symbol right here for the phrase such that. I didn't make that up, by the way. It's a fairly common notation.
There's no symbol for whenever?
Yeah, there is. It's a shorter word. I usually say, if this is true, then that's true. Actually, symbolically, I'll do this. I just thought I was being too extreme already with my
Is there actually a class that teaches you all this
The
notation?
notation?
Yeah.
No, hopefully it's something you're just building up upon as you
Okay.
progress through your maturity in mathematics. But discrete mathematics, don't yell at me, it really helps a lot.
Okay.
Come on, you guys, help me with this. What do you think? Just say something, panic.
Convert
You
to
math
x.
30 experts, panic. So 1 to the infinity power, what does that suggest to you?
It's converging to e.
Well, L'Hopital is a theorem I can use to value a limit. If the limit of values to infinity over 0 over 0, which is certainly not the case here,
Converges to e.
something involving e. So how do you find it? What do you mean split it up? Okay, here's the key. Let's talk about the 1 to the infinity power situation. So I got some function f of x going to one of the base positions, some function g of x going to, infinity in the exponential position. So it's 1 to the infinity power. If the function of base position is approaching 1 so darn faster than the exponent is going to infinity, I think the whole thing will go to something close to 1. But what if that exponent is going to infinity so much more quickly that the base is going to 1? Then I think the whole thing could potentially blow up to infinity, or maybe something in between. It's a race. Maybe not a L'Hopital's race, but a race. And I think what we need to do is take a break. Give this thing right here a name. Take the natural log of both sides.
Variable power.
I said, take the natural log of both sides, but legally. Sorry. And then 1. And then 1. That would just get me where it started. In fact, I I know a few of you from Math 30. This disturbs me, disturbs me.
It's 0 times infinity, so it's only.
Another indeterminate form. Is it 0 times infinity? Yeah, it is.
Would applying the log properties help?
Could you combine the two terms inside the natural log?
I could, would do me
Is
good.
that logarithmic differentiation?
I've already taken the log
Would,
class.
would log properties of logs help?
Um,
Or
Maybe
not?
not properties of logs. You guys, it's a 0 times infinity situation. What do you do with 0 times infinity?
L'Hopital.
No, yeah.
You can only use L'Hopital as 0, 0.
You have to
infinity.
do math, do you tweak the form?
It is another indeterminate form, but how do I handle it?
You have to do an algebraic technique to turn it
Algebraic
0, 0.
manipulation to force a 0 over 0 situation or infinity over infinity situation. I'm going to rewrite this right hand side as nothing more than, I don't know, how about the natural log of 1 plus 2 over n divided by 1 over n. Oh, did I forget my 3? You just not care about it. Now, as n increase up bound, don't we get a 0 over 0 situation? For which L'Hopital's rule does indeed apply.
Yes.
And so in using L'Hopital's rule, you guys help me with this. How do I compute through this natural log?
1.
Remember I called you Math 30 experts. How do you differentiate this natural log?
It's
A
1 over.
The answer is you don't. You have no mathematical legal right, because Randall, this now comes down to playing the case. If I'm going to differentiate, I need a continuous function. Did you guys see my point? So I think at this stage of the game, I have no choice. I got to come in and rewrite this as a function in x. So rewriting, it could have been earlier than now, but at least at this stage, no, it's right in front of me. At least at this stage of the game, I now have that the natural log of y is equal to 3 times natural log of 1 plus 2 over n, all over the 1 over n thing. Excuse me, I said, rewrite as a continuous function. Now I've got the right to differentiate both sides. So applying L'Hopital's rule, I see that my 1 over y times y prime is nothing more than
So why is it necessary to change it to x if it doesn't do anything?
Yeah.
It's just gonna
See,
float
I
back
think it
in.
does a lot. Think about it. If I'm going to apply L'Hopital's rule, I'm going to rewrite this fraction as a ratio of derivatives, and I can't differentiate because I've got a continuous function.
But isn't that not continuous at 0?
Say that again.
Isn't that not continuous at 0? At
Yeah,
x
but you
equals
know
0?
what? I don't care. Because I think when it comes to my sequence, I'm going to want n to be 1 on up.
Okay.
So I really don't give a darn what happens to left of 1. Can you guys look at what I've done on the board? I'm not trying to trick you, but that's a horrible mistake. I didn't mean that. I mean, my job right now is to do this. Take the limit of each side. And taking the limit as n increase up bound of my natural log of y is indeed equal to the limit as x increases without bound, which apparently I can't write, of 3 times the natural log of 1 plus 2 over x all over my 1 over x. And since I do indeed have a 0 over 0 situation, I have the mathematical legal right to employ L'Hopital's rule. And L'Hopital's rule says this limit is equal to the limit as x plays its game of the derivative top over bottom. But the derivative top is going to be nothing more than this. Let's see, the differential natural log of anything, blindly, don't I just get 1 over that?
2 over x, yeah.
But I'll multiply by the derivative inside, which is nothing more than 2 times the derivative of 1 over x. Now the derivative downstairs is nothing more than a negative 1 over x squared. Oh, by the way, I keep losing that lingering 3. I'll put it out front. You guys see why I'm writing that derivative in red? Nice cancellation. Not only do these two cancel, I think if I now evaluate this expression as x increases without bound, is it not true that the second term downstairs just goes to 0? And I think the only thing I'm really left with is just a positive 6. So I maintain the limit of my a sub n as n increases without bound is equal to the limit as n increase that bound of e raised to the power of the natural log of my y. It's just that e is a continuous function. I can rewrite this had I taken the limit of the exponent. It's just that I've already found that the natural log of y goes to, oh, look at that, my positive 6. So I think this particular sequence converges, and specifically it converges to e to the 6. Do you guys agree? I'm just shaking up on your map 36.
On the, that part right there, limit as natural log of y of n goes to infinity, are we allowed to, within the same graph or within the same function, take n as n versus infinity and on the other side is x versus infinity?
Yes, because I think as n increases that bound, so does x, even though x is a continuous variable.
Okay.
How about this one? How about an easier one? Same question. But a sub n is equal to this. What do you think it converges to? Did I write wrong in the right class?
Doesn't converge.
That's not. You guys, while you're thinking, can I raise the board? So I can put my calculator. Well, if you guys aren't going to give me an answer, then how about if you and I just generate what it should be visually speaking, and then see if we can determine analytically if they're correct. So visually, am I up yet or not? Oh, yeah. So visually, let me type this into my calculator. Oh shoot, it's not there. Just a minute, let me clear everything out. So my y sub n is equal to, what was it, n over? Where's my n? Oh, here it is, x. Oh. Hold it, I need the n, it's not showing up. I said I need the n, because that's not showing up by this key.
Converges to 1/2.
I guess it's different.
X.
I want an n on my screen, how can I get an n?
Change the mode.
Yeah, go into the mode. If I dive in the mode, check out how I can change from function mode to parametric mode to polar mode. You guys messed with all this stuff back in Math 29. And even, oh, look at this, sequential mode. Now when I hit enter, and I go back to my equation editor, check out what happens when I use my variable key right here. It shows up as an n. Help me. Is n divided by n plus 1? I don't remember.
Yes.
And I want to graph it. Oh, but I can't, you guys. I walked in this room this morning, and I don't know who's been in this classroom. So can I just very quickly affect my window? Just so what I get makes sense. I like how my n's are ranging. But I want to choose, actually I don't. I choose that -1. No, it looks good positive 1. I want to change the x to a -1. To have it a positive 10. And let me go ahead and look at how my y's are changing. Oh, way too much. Can I go in here and change these, you guys? How about a -0.2 to a 1.3? Now on a graph. Oh, look at that. Seems to me, graphically speaking, that if this is a sub 1, which is a half, and here's a sub 2, which is 2/3, a sub 3 is 3/4, seems to me I'm kind of leveling off.
Looks like
Seems a
it's,
little.
looks like it's hitting an inflection point.
You know, that's just
Yeah,
because of
that
an
is.
anomaly with the computer screen, the calculator screen. I know, I'm seeing the same thing you are, but it's just the calculator's not that good at plotting these points. But I do think there seems to be a limiting value. Let's see if you can apply a little bit more.
It'd be 1, wouldn't it?
What's that?
Wouldn't it be 1?
Yeah, I agree. Because when I take the limit, as n increases with that bound, you guys, you've stalled way too long. Can I overdo this one? So let me show you my notation. This is equal to the limit as n increase that bound of this. If you were to apply L'Hopital's rule, you're a fat out of luck, because that's not a function of x. So you and I are going to rewrite this as a limit as x increases with that bound of x over x plus 1, where are you guys? All I'm really suggesting is that here's my function f's output. It's just that f evaluated x, if x is restricted to the positive integers, is nothing more than the nth term of my sequence. You can think of my sequence as nothing more than a continuous function with its continuous variable restricted to the domain, in this example anyways, of the positive integers. Yes, sir?
I still don't understand why you haven't changed the variable from n to x.
I don't have to, it's just if I apply L'Hopital's rule, then I have to rewrite everything as a continuous function so that I have the right to differentiate. Because I think if I am going to apply L'Hopital's rule, it suggests that I can rewrite this limit as a limit of the derivative of the numerator over the derivative of the denominator, but I can't differentiate anything but a continuous function.
So why is it not continuous if you have n in there and continuous if you have x in there?
Well, look at the output of the function. It's horribly discontinuous. Those
Okay.
points aren't connected.
Oh, okay.
Now, I think if you graph my function f, what that looks like is this. It's a rational function
Okay.
with a horizontal asymptote. And sir, to continue attacking this notion, let's suppose you want to differentiate. What does derivative mean graphically? It means you're talking about slopes of tangent lines. And if I were to talk about slope of this tangent line at any value of x like this one right here, can't do it. There's no point of the curve. So I made a mistake. Let's talk about the derivative at this value of x. Can't. Because derivative means I'm looking at either side, looking at slopes of secant lines, seeing how the secant lines are changing as I get closer and closer to that value of x, and I can't get closer and closer because they're only discrete values for n, not continuous values. I do think, however, should I apply L'Hopital's rule again, you guys?
No,
What do you mean, no, why not? I can differentiate one. What's worse than that? I have no right to apply L'Hopital's rule because that's not one of my standard indeterminate forms. 0 over 0, infinity over infinity. I'm done. This is just equal to 1. Do you guys not like the way I'm doing this?
it's lovely.
It works.
I was hoping you'd say, yeah, I don't like it because I don't think I like it. It's overkill. Why apply serious tools of mathematics when I can apply simple ones? Because I think when it comes to the limit, as n increases for that bound, of my n over n plus 1, why not just say this is equal to itself? Just multiply top and bottom, like you did in Math 30, by 1 over n to the highest power you see downstairs. That's simply going to give me the limit as n increases with that bound of 1 over 1 plus 1 over n. But jeepers, you guys, as n increases that bound, what happens to the second term downstairs?
0.
That being the case, I'm finally left with a positive 1. Get the same answer. Or do you not believe me here? Please.
Well,
I'm hoping you say you don't believe me.
if it's not continuous, then how can you do that?
Okay, now wait a minute, Brady. There's no problem with me taking the limit as n increase that bound. There's just a
Okay.
problem with me differentiating. Because I know I've erased it, but on this right-hand board, I really did give you a formal definition of the
Okay.
limit of the nth term of sequence. I can take limits as n goes to infinity. It's just that somewhere along the way you want to differentiate. Like, for example, applying L'Hopital's rule, then I'm in trouble. Then convert to continuous functions.
Okay.
But with my second approach, I never differentiated, so I think what I've done with limits, it's okay. There's only one small issue. You guys should attack it with my new definition as to whether or not 1 over n goes to 0 as n increases that bound. Do you believe it's true?
No.
See, I personally believe it is true. It's just that I think we should be able to prove it with my definition. So you ready? We're all coming from different places. Have you all had practice proving limits with your epsilon delta definition?
Mhm.
Okay, you're shaking. Some of you won't look
Yes.
me in the eye. All right. Let me get rid of this. Theorem. The limit as n increases that bound of 1 over n is indeed equal to 0. Let's prove it. Let's find an n that works. So given an epsilon greater than 0, we need to find In absolute values, my a sub n minus L is no more than epsilon units, whenever. And after, I said in absolute value, excuse me, whenever lowercase n is chosen big enough. Now, just like with your epsilon delta proofs, I'm trying to rewrite each one of these inequalities so I get the same darn lower bound on both sides. So let me dive in and replace a sub n with what it is, and L is what it is. And let me clean up. Do you guys mind if I suppress absolute values at this point? Because I'm going to allow n to range from 1 on up. So I think for free, that first term is always positive. But I think this implies that epsilon times n is greater than 1 whenever n is at least as big as n. But this implies that n is bigger than 1 over epsilon whenever n is at least as big as n. Or how about rewriting? N is at least as big as 1 over epsilon whenever n is at least as big N. But you guys, what I have on the ink board, check out what both these two statements say. That I've got a lower bound for n. One's 1 over epsilon, one's big N. It tells me how to choose my big N. I'm going to choose big N to be equal to 1 over epsilon. Does everybody in this classroom see what I've proven? Everybody. What have I proven?
Nothing.
Thank you. If you look at what I have on the board, I've proven absolutely nothing. This is just my scratch board. Now to formalize my proof, let's show that this particular choice for n works. In other words, given an epsilon greater than 0, choose your big N to be equal to 1 over epsilon. Now, if I make the supposition that x is at least as big as, excuse me, I misspoke, didn't I? Sorry, I meant, if I'm going to choose my little n at least as big as big N, that if I can show you that in absolute values, a sub n minus L is no more than epsilon units, that I've proven to you with my definition that the limit of a sub n is equal to L as n increases that bound. So you guys, now it's just an algebra game. So with my algebra tools, let's fill in details. I didn't realize I had room. I'll split my room. I think a sub n is just this. My L is just this. I think that just simply gives me the absolute value of 1 over n. But since n is always positive, the whole thing is going to be positive. But if you guys take a peek at how I chose my little n, doesn't that suggest that 1 over n is going to be less than 1 over big N? Be honest. Is my algebra okay? All right. But I chose my big N to be, actually I forget, let me look up here. It's just a 1 over epsilon. But jeepers, now when I reciprocate, that's just simply epsilon. Therefore, I have indeed proven that the limit of 1 over n as n increased that bound is indeed equal to 0. I've proven what I wanted to show. But you guys, this is a mathematical proof. That means at any stage of the game you can attack me. I need to verify that what I said is correct.
This isn't a game.
What's that?
This is not a game.
It's not a game. But seriously, you guys seem, because you're not getting any flags, seem to have practice with your epsilon delta proofs, at least some degree, in the past.
Where's the delta?
Yeah.
Well, I have to confess, this is a little bit different than my epsilon delta definition of limits back in Math 30, because now I'm dealing with sequences, not just simply continuous functions. So instead of saying, oh, the f of x goes to L as x goes to A, where x going to A by no more than delta units, this time I'm just saying my a sub n goes to L if I choose my little n big enough out there on the horizontal axis. So I admit, it looks a little bit different, but the same idea underlying it.
So, would this be like a test question? Would you want us to actually prove this?
Oh yeah, because you've already proven you can prove the epsilon delta proofs back in.
Okay.
So how much time do we have on this test?
2 hours will be good enough. That'll be sufficient. I lost my numbers, you guys. What exam am I on? 6? 6. All right. I'm worried I'm going to be inefficient with the time we have left. Can I cheat? I made up some examples. What about this one?
Converges
Converges to
to one.
what?
One.
Converges to...
Zero.
What did it converge to 0?
That's zero, that's right, yeah. It's a P series.
So if I'm asking the question, is this particular sequence monotonic, what I really mean is this: is it strictly increasing and or strictly decreasing?
Yes.
Or neither? But how would you find out?
You take out a graphing device and plot it.
I'm tired. At a glance, do you think it's increasing or decreasing?
Decreasing.
Oh, you guys, hold a minute. Hold it. Oh, sorry. I need to restate something. Are you ready? If I plug one in for n, what do I get? Something undefined. So for this particular example, I'm going to start my sequence, just to make this legal, at 2, not 1. Because at n equals 1, this particular sequence is not defined. I do have to state that officially. So, let's check it out. Let's plug 2 in for n. If I plug 2 in for n, what do I get? Is that a 2 over negative 3? But if I plug 3 in for n, I get 2 over negative 8, which is negative 1/4. Say that again. Oh, sorry. I get negative 3/8. My goodness. And I know you guys only check it for 2 values of n, but does it seem to be getting bigger or smaller? Say it again. Yeah, I think it's getting bigger. I think it's getting bigger. I can show you that it is. Watch. I just need to check that my a sub n plus 1 is less than my a sub n. Let's see if it's true. Let's talk about a sub n plus 1, which, by the way, is nothing more than n plus 1 all over 1 minus n plus 1 squared. But you guys, I think that's the same thing as n plus 1 over 1 minus n squared. Okay, I made a mistake. Here's my mistake. What I'm subtracting from 1 here is bigger than it was before, but it's downstairs, and the numerator is the same. And so I think my denominator is getting larger or smaller from here to here.
Larger.
Therefore, the fraction is getting smaller.